Okay guys, in this video we're going to use a textbook page. We're going to use some fraction strips that I made. We're going to use some fraction circles, and what we're going to be doing is talking about how you can represent whole numbers with fractions. Okay, there was another video, Khan Academy video, that I wanted you to watch, so hopefully you've already watched that. If not, you can watch that after this one, because there will be 5 problems for you to answer on Google Classroom, and if you've watched both the videos, the Khan Academy and this video, you should have no problem answering those questions correctly. So this is page 511 in your textbook. If you could open your textbook to page 511, that will be helpful because you can refer to this page to answer the questions on the Google Classroom form. All right, so it says here you can use fractions to name whole numbers. So this is a whole, one whole. Let me zoom in. This is one whole. This is another whole, this is another whole, this is another whole. So this is actually 4 wholes. So the number 4 wholes. And they're showing you that one whole would be, if we were doing thirds, you would have 1/3, 2/3, 3/3. Okay, 3/3 is one whole. So they're showing that if you had 4 wholes, you would have 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, 11/3, 12/3. And if you know your multiplication, 3 times 4 is 12, 12/3. So if it says 12 1/3 fraction strips equal 4 whole fraction strips. All whole numbers have fraction names. So you could name it a whole number or a fraction. Just like you might have 2 different names, but you are the same person. So it's the same value if you have 1 whole or 3/3, or 4 wholes and 12/3. You can write 4 equals 12/3. Okay? Again, 3/3 is 1. If you have 12/3, that's 1, 2, 3, 4. You also know 4 equals 4 over 1. 4 wholes is 4 over 1. So you can write 4 equals 4 over 1, or it's also equal to 12/3. Okay, 1, 2, 3, 4. 4 wholes. It's divided only into one part. That's what 4 over 1 means. Okay? All right, so let's go here. It asks you, explain how you know that 4 over 1 equals 4. So they're showing us here, remember that the numerator is telling you how many there are of something, and the denominator is telling you how many parts it's broken up into. So if we're looking at, let me get this ruler to try to kind of block this part out. That's not going to work. Hold on one second. Okay, let me just cover this part up. Okay, so 4 over 1 means there are 4 pieces, and each of the pieces is just broken up into one part. 4 wholes, and each of the wholes is just broken up into one part. Like if we had 4 of these broken up into one part. So again, the question is, how do you know 4 over 1 equals 4 wholes? Well, the numerator shows how many strips there are and the denominator shows how many parts, well, how about I say each strip is broken into. So when it's 4 over 1, that means there's 4 holes, and each of the holes is broken into just 1. I don't really want to look at this number line right now. Let's just look at number 3, and I'm going to use what I have for my fraction strips to explain these questions. It says, look at the number line, but instead of, goodness gracious, write 2 equivalent fractions for each whole number. So here's what I'm going to do instead. I have the whole number 1, and I want to know how many thirds are equal to the whole number 1. How many thirds are equal to the whole number 1? 1/3, 2/3, 3/3. They also want to know, though, so I'm going to put that above that, how many sixes, 6, are equal to the whole number 1. 6 sixes. 6 1/6. Okay, so I'm going to put 3/3, because it takes 3/3, 3 1/3 to make one whole, or 6 1/6 to make one whole. Then they have 2 holes. Now let me zoom this back a little bit so I can fit my 2 on there. And I color-coded them. But because they're paper, they kind of move around. There you go. All right, so we have 2 holes. They want to know 2 holes would equal how many thirds? Well, if 1 hole is equal to 3/3, then 2 holes would be 3 more thirds, which means 2 holes is equal to 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, because you need 3/3 to make one hole and 3 more thirds to make another hole. So this would be 6/3. Let me zoom in so you can see that. This, by the way, you'll learn in another grade is called an improper fraction, because the numerator is bigger than the denominator. Okay, so again, they're looking at the 2 holes, and they want to know how many sixths you would need to make 2 holes. Well, we know it takes, if we divided it into 6 parts, it would take all of those 6 parts, 6 to make one hole. So to make 2 holes, it's going to take another 6, which means it's going to take 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6, 8 6, 9 6, 10 6, 11 6, 12 6. 6 6 is one hole. 6 out of the 6 pieces would give you one hole. You'd need another 6 out of 6 pieces to make 2 holes. Okay, some of these questions down here I've actually put on the Google form that you're going to do. So I would pay close attention and make sure you're writing the correct answers. So when you go back Let me first focus it because you can't really see it, so that's not going to help. There we go. Okay. They're asking if I had 4 holes, how many halves would I need to make 4 holes? Well, this time I'm going to use one of these circles. This is 1 hole, right? And there's 2 halves and 1 hole. So if I needed 4 of these, that means I would need to have 4 circles that had 1 half, 2 halves in them. So I need 1 half, 2 half, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves. Okay, again, 1 hole is the same as 2 halves. So if they're asking me how many halves are in 4 holes, that means I have to have 2 halves, another 2 halves, another 2 halves, another 2 halves. So if I think of, if I do skip counting by 2, 2, 4, 6, 8. That's 8 halves. 8 halves. And if I didn't break this hole up, if I just kept it a hole, that means I would need how many holes over 1? How many would I need? Because this is, a hole is 1 over 1. That's how you represent it. Okay, so if I needed to have, if I wanted to show 4, I would need to have, this is 1 over 1, this is 1 over 1, and I would need one more 1 over 1. So I would need 4 over 1. 4 over 1 is the same thing as 4. 1 hole. How many fourths are in 1 hole? Well, let me take the fraction strips for this. And there's a hole. Where's my hole? Okay. 4 fourths equal 1 hole. Now, where are you, my little circle? Where are you, my little circle? Oh no, it's Batman again. Okay, hold on, Batman. I'm looking for my fourths. Oh, goodness. I think, I found it. I thought Batman messed with it. And it flew out of my hand. Okay. 4 fourths equal 1 whole. This is 1/4, 1/4, 1/4, 1/4, 1/4, 2/4, 3/4, 4 fourths equal 1 whole. 4 fourths equal 1 whole. Here's a hole. Here's a hole. To write 1 whole as a fraction, you just put 1 over 1. It's 1 piece broken into 1 piece. All right, next one, they have 2. 2 holes is how many thirds? Didn't we just do that? Yeah, we did. Look, it's right here. 2 holes is 6 thirds. 2 holes is what over 1? Is 1 1 and 2 1s. It's 2 holes broken up into 1 piece. 5. I don't have 5 holes. But let me do this. Oh, that's why I had my whiteboard. I forgot. I got so distracted with Batman that I forgot why I had my whiteboard here. Let's pretend that these are the exact same size, because it only works if they're the exact same size, and I know they're not, but I'm going to break them into halves, and let's pretend also that those are exactly halves. So for this 5 holes, how many halves do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 equals 10 halves. 5 equals 10 halves.
Call from Winston-Salem.
Okay, so if I had these, we're getting our nightly call, guys. Alright, so 5, I had 5 of holes. So again, that would be like 1, 2, 3, 4, 5. 1 hole you represent with 1 over 1. 1 over 1. It's 1 hole broken into 1 piece. So that would be 1, 2, 3, 4, 5 over 1. 5 over 1. Okay, let's look at these last few problems. So here it says, for each pair of fractions, write the equivalent whole number. And these are the ones that I think I put on the Google form. So I would pay very close attention to these. Still working on that. Still working on that focus. That's better. Okay. 6 over 2, 3 over 1 is what whole number? 6 halves. 6 halves. Let's get my half strips. Six halves. There's two. There's 2 more. There's 2 more. 6 halves is how many holes? That's right. It's 3 holes. Or 3 over 1, that's meaning 1, 2, 3. That's equal to 3 holes. That's what whole number that's equal to. So 6 halves, 3 over 1 is equal to 3 holes. 3 over 3 and 6 over 6. Anytime you have a numerator and denominator that are the same, that's equal to 1 whole. 3/3, 3/3, and where's my 6/6? 6/6 is equal to 1 whole. So it's equal to 1. 8/4 and 6/3. So let's do this. Here's 3/3 and 3/3, 6/3. How many holes is that? 2, but let's just make sure, because the other thing they wanted it to be equal to, they want to know 8/4. So let me get my, here's 4/4, and where's my other 4s? There you are, there you are. No, that's not you. Oh, you would think by now I would get myself more organized. So I'm going to do this. I'm going to put them lined up, and I'm going to pull this down. Okay. Move out of the way, you guys. 6, 6. And 8 fourths. How many holes does that equal to? Those 6 thirds. I'm sorry, 6 thirds. So 6 thirds equals 1 2 holes. 8 eighths equals 1 2 holes, because again, right in the middle we put 1 2. 6 thirds, 8 eighths equals 2. Alright guys, we are almost done. My dinner's downstairs and I'm hungry. Okay. Thirds and fourths again. Good, because I have them out. Alright, so now they want 9 thirds. 3, 6, 9. How about if I do this to make it easier for you to see it? Three, 6. Well, I'll put the 9 here. 3, 6, 9 thirds is equal to 1 2 3 holes. See? 1, 2, 3. Okay. And then 12 fourths. So let me get my fourths. 4 fourths. Another 4 fourths. So that's 8 fourths. And another 4 fourths is 12 fourths. 12 fourths is equal to 1 2 3 holes. And 1 3 6 9 thirds is also equal to 1 2 3 holes. So now we'll zoom in. 9 thirds and 12 fourths equals 3. Alright, now that you've done this video with me and the Khan Academy, you can go into Google Forms and answer those questions. And Batman says, good night. As does Biggie.